In this video, I'll demonstrate how to configure parameter starting estimates and constraints using the advanced settings for a user-defined fit in the MyCurveFit.XL add-in. These advanced fitting features assist in guiding the fitting process, providing further control over, and offering an improved fit. Coefficient starting estimates are where the fitting optimization process starts from. The better these are, the better the fit. Constraints define a permitted range for each coefficient. These can be used to direct the optimization process and can assist with avoiding local minima or invalid coefficient values, such as avoiding negative values where only positive values are valid. For this example, I'll be working with the 5PL fit method. However, I will configure this using the user-defined function and manually applying the fit equation to allow us to add estimates and constraints for some of the parameters. The MyCurveFit.XL add-in offers a built-in 5PL function, which is simpler to use and automatically sets estimates, but we'll use the advanced method for more control over fitting. I have open an Excel spreadsheet with calibrator X and Y values. In addition to the calibrator values, we also have our fit equation. First, let's apply the 5PL fit using the user-defined function with no estimates or constraints for the parameters. To do this, we can highlight the number of cells required to house our parameters, in this case 5. I'll also include an additional cell to report the R² value and an additional row to contain the headers. We could type equals MyCurveFit and select the required fields as we did in our previous user-defined fit method video, but for this example, I'll instead use the Formulas tab. Select Insert Function and select the MyCurveFit category. I'll scroll down to the user-defined option, highlight the calibrator X values, Y values, and fit equation. Now I'll press Ctrl-Shift-Enter to apply the function. Here you can see our parameters are calculated along with the R² value. The R² value is lower than I'd like it to be, so we can improve the fit by adding starting value estimates and constraints. I've created a table here to house the parameters and 3 columns to show the estimate, constraint min, and constraint max. To allow us to populate the parameters in the order they'll be used in the function, we can highlight these 5 cells, add the user-defined-coeffs function, highlight the cell containing our fit equation, and press Ctrl-Shift-Enter. This adds the parameters to our table. This table can contain as many or as few estimates and constraints as are required for our fit. Let's go ahead and apply the UserDefinedAdvanced function with a blank table so we can view how the estimates and constraints impact the parameters in real time. Again, I'll highlight 5 cells to house the parameter values, an additional cell to house the R², and 1 more row to include the headers. I'll insert a function, and this time I'll select to use the UserDefinedAdvanced option. I'll highlight the calibrator X values, Y values, fit equation, and our fit estimates and constraints table. Pressing Ctrl-Shift-Enter returns the same values as originally calculated because we've not added any values to our estimates or constraints table yet. First, let's add starting estimates for A and D. To do this, I'll add the minimum Y value for the A parameter and the maximum Y value for the D parameter. We can use the min and max functions in Excel to return these values for us, entering equals min and highlighting the Y values for the A parameter, and entering equals max and highlighting the Y values for the D parameter. You can see here the parameters have automatically been updated and our fit is already improved as evidenced by the R² value here. Now let's focus on the parameter values. In this case, the A parameter is less than the D parameter, and both the hill slope and the asymmetry factor, or M, are negative. If we'd like to ensure a positive hill slope, or parameter B, we can add the minimum constraint of 0 for the B parameter. By making this change, you can see the hill slope and the asymmetry factor M are now positive. We can also use the constraint min and max to swap the A and D parameters, essentially flipping the equation. To do this, I'll add a constraint min of 3600 for parameter A and a constraint max of 200 for parameter D. Now you can see the A and D parameter have been swapped. To illustrate how adding coefficient starting estimates and constraints can improve the overall curve fit, I've created two different charts. One using the 5PL fit without estimates or constraints, and one with estimates and constraints. For more information on how to create curve charts, please see the associated video. In these two charts, the blue line is representative of the fit, and the orange dots are our calibrators. This first chart with no estimates or constraints shows a poor fit, with the curve line passing through only a few of the calibrator markers. However, by adding starting point estimates and constraints, you can see here the curve fit is greatly improved. There's also a weighted version of the MyCurveFit.UserDefinedAdvanced function, allowing you to apply weight values to the calibrators. So, by using the UserDefinedAdvanced function and applying starting point estimates and constraints to our curve fit coefficients, we have greater control over the fit. If you have any questions about how to use the UserDefinedAdvanced function in the MyCurveFit XL add-in, please email us at support@myassays.com.